Hey everyone, and welcome to the last last day of Unit 8. And I know it says long division integrals. We're not going to do those. We're going to do the first page of u sub integrals, but looking at definite integrals. So what I've got here is how to do this problem, how you know how to do it right now. So u x squared plus 1 du 2x dx, and as a result, we're going to get 1/2 of the integral of 0 to 2 of u to the 5th du. Take the integral of u to the 5th, u to the 6th, over 6 from 0 to 2. Now, in this case, though, these bounds work when they're in terms of x. So what we need to do is plug back in for what u is. So x squared plus 1 to the 6th. And then you can see what I have here is how you would do that. Now, don't need to write this down. I just wanted to show you what you would do with this problem with u substitution. Now, this is a long way of doing it. So what I want to do is show you the short way to do this. The key thing here is, one, we're going to find u and du. We're going to change the bounds. So we want to be in terms of u. Rewrite integral in terms of u, and then compute definite integral. So those are our 4 steps. So in this case, we already found u and du. But over here, we got to change the bounds. And so one thing that I like to do is always go top to bottom, just so we don't get confused. So 2 squared plus 1 equals 5. That's our upper bound. 0 squared plus 1 equals 1. That is our new lower bound. So this is our upper, our lower bound. So we're going to rewrite the integral. 1/2 u to the 5th du from 1 to 5. Now the bounds are in terms of u. Now the nice thing here, and why we like this, is so that we can compute it. U to the 6th over 6 from 1 to 5, and now we don't need to plug back in what u is. So 1/12, why can I take the 1, why is it 1/12? I can take the 6 and the 2, and since they're denominators and constants, I can bring them out, of 5 to the 6 minus 1 to the 6. And why do I like doing these side by side? Well, look at this. They're the same thing. This is the 2 squared plus 1 is how I got 5. 0 plus 1 is how I got 1. So now I get the same thing. 1/12, 15,624. And we know that's 1,302. So again, find u du. Do what we usually would do for u substitution, but we have to remember to change the bounds. Okay, let's go for this one. So we know u, well, we can rewrite this as sine 2x all to the 5th cosine 2x. So obviously it's u equals sine 2x. Du is 2, make sure you remember chain rule, 2 cosine 2x. I'm going to just change the bounds over here. Kind of ran out of room here. So our bounds, what u is, so I'm going to do the upper bound first, sine of 2 times pi over 8, which is sine of pi over 4, which is square root of 2 over 2. Some of you may remember from algebra 2 or pre-calc, that's also the same thing as 1 over square root of 2. So that's our upper bound. Our lower bound, sine of 2 times 0, which equals sine of 0, which is 0. And so we now have 0 to square root of 2 over 2. Make sure that we do du over 2 equals cosine 2x, so we remember that. So we're going to get 1/2 the integral u to the 5th du from, make sure we don't forget those,
0 to square root of 2 over 2. Okay, well, notice we still have the u to the fifth just like we did over here, so we're going to get the integral of u to the 6 over 6 from 0 to square root of 2 over 2. We know that's 1/12 of u to the 6 of 0 to square root of 2 over 2. And so now we have to kind of look at this and say, if we didn't have a calculator, how would we do it? Well, square root of 2 can be written as 2 to the 1/2. We multiply exponents, so it's really saying 2 to the 3rd. And we know 2 to the 3rd is 8. 2 to the 6th is 64, minus 0, so we're done. And that's really saying 1/12 times 1 over 8. And so we're looking at 1 over 96.
Again, if you had to, you could plug that into your calculator and get an answer. It doesn't work as well if that was to the 7th, though. You would need to know it was 8 square roots of 2. Okay? So our final two problems here. We look here, this is underneath the radical, so u equals 1 plus e to the x, du, e to the x dx. So we've got there and there. We're going to change our bounds. We're going to get 1 plus e to the ln of 3 and 1 plus e to the 0. Those are our two u's right there and there, our two bounds. So I plugged them into where the x was. This is 1 plus 4, e and ln are inverses of each other. We're left with, sorry, not 1 plus 4, 1 plus 3, which equals 4. And e to the 0 is 1, and so we get 1 plus 1, which equals 2. Nothing that we need to divide by here, so we're going to get the integral of 2 to 4 of the u to the 1/2. That's another way to write square root, du. So we're going to get u to the 3/2 divided by 3/2, from 2 to 4. And so we're left with 2/3. I'm just going to plug in right now 4 to the 3/2 minus 2 to the 3/2. And then everyone starts to freak out because we say, oh no, how do we do 4 to the 3/2 or 2 to the 3/2? How do we evaluate it? Well, let's look. Anything divided by 2 means square root. So this is also saying the same thing as square root of 4 cubed, square root of 2 cubed. Well, what's the square root of 4? 2 cubed, 8. Minus, you could look at it as this if you wanted to. I have no issue with that. And I guess the final step that I would say here is we don't need to combine, but we could take out a 2. So we're going to get 4/3 times 4 minus square root of 2. We can leave it like that. You could have done 16 minus 4 square roots of 2 all over 3. Doesn't matter to me how you do it, but that would be a version of a final answer. And the last one that we need to do here is, well, we see a fraction, and we're going to need to get rid of that. So u is going to be 1 minus x. So not get rid of it, but we've got to substitute that one. So du equals negative 1 dx. So we got negative du to equal dx. So we got that there. And now we've got to change the bounds, so let's make sure not to forget that. That's the most common mistake in this problem, is everyone forgets to change the bounds. So we got 1 minus 3/4 and 1 minus 0. We get 1/4 and 1. Now, here's one of the things that people sometimes get confused on is usually when we go to bounds, 0 to 3/4 goes smallest to largest. In this case, when we change the bounds due to u, we now have a larger number in the quote lower bound. That's okay. That will happen. Do not get confused by that. So we're going to get negative integral, due to that negative right here, not negative. Negative integral of 1 over u du from 1 to 1/4.
And we know the integral of 1 over u is the ln of u. Negative of that, you get it? Negative ln of u of 1 to 1/4. And so we get negative ln of 1/4 minus ln of 1. And that negative we need to make sure is in parentheses there. And so we're going to get negative ln of 1/4. The ln of 1 just goes to 0, so we're left with negative ln of 1/4. To recap, to do any u sub definite integrals, always find u du. We didn't change anything there. The one thing that changes from regular and definite u sub is we gotta change the bounds. Once you change the bounds, solving for a definite integral stays exactly how you would expect it to. So the joke of the day comes from my wife. What happened to the plant in math class? What happened to the plant in math class? It grew square roots. It grew square roots. That's a good one. Thank you to Sarah for that one. See you guys all in class.